Presented by Caltech.
Neil Gehrels is the chief of the Astroparticle Physics Laboratory at NASA's Goddard Space Flight Center, and an adjunct professor of astronomy at both the University of Maryland and Pennsylvania State University. He is famous for his investigations of gamma-ray blasts, including leadership of NASA's Swift gamma-ray burst mission, providing fundamental insights into some of the most explosive and violent events in the cosmos. Dr. Gehrels began his academic career at the University of Arizona, where he studied to be a classical music composer. Only after finding work in a campus lab studying high-energy particles from space, cosmic rays, did he add a physics degree during his junior year. Dr. Gehrels worked with Ed Stone for his doctoral research at Caltech, helping calibrate the cosmic ray instrument that would launch aboard the Voyager spacecraft. Before graduating from Caltech with a PhD in physics in 1982, he met chemistry PhD student Ellen Williams. They were married here on campus in Dabney Gardens, and as it turns out, are both being honored today for their individual pioneering accomplishments as distinguished alumni. After completing his PhD, Dr. Gehrels joined NASA's Goddard Space Flight Center, where he has remained, providing first-rank intellectual and administrative contributions to missions from infrared to gamma-ray astronomy to gravitational wave detection. Fiona Harrison, Caltech's Benjamin M. Rosen Professor of Physics and the Kent and Joyce Cressa Leadership Chair of PMA, describes Dr. Gehrels as one of the most distinguished leaders in space astrophysics, saying, "In addition to having many important scientific contributions, Neil's calm, deliberative style, together with his careful approach, makes him particularly effective at the helm of large teams." We honor Dr. Gehrels for his scientific leadership in the study of gamma-ray bursts, as well as for his significant contributions to high-energy astrophysics, infrared astronomy, and instrument development.
So I'd like to thank Caltech and the Alumni Association for this tremendous honor. Like Eric described, when I was a young physicist, I was thinking only of being a theorist and following in the footsteps of Feynman and Gell-Mann, and that was my dream. And then I came here to Caltech, and luckily I stumbled into the laboratories of Robbie Vogt and Ed Stone, and really got hooked on space astrophysics. They were building a cosmic ray instrument that was going to fly by Voyager. I participated in calibrating it and working on it and analyzing the data, and it was just the best possible start to my career that I can imagine. And another wonderful thing that was referred to is that I met my wife Ellen here. We both lived in Keck House, the graduate dorm, and she was one of 3 women in a graduate dorm with 70 guys, and that's the way it was in those days. And I was the lucky one. So then I went to NASA in the new field of gamma-ray astronomy. And as you know, I'm sure, stars and galaxies in the universe emit their radiation over the whole electromagnetic spectrum, from radio waves to the visible that we see, to X-rays and gamma rays. It's surprising to many that even a penetrating radiation like X-rays doesn't get through the Earth's atmosphere. It's really in these narrow bands like the visible band that we can see out. And so it wasn't until the space age that we were able to launch satellites above the atmosphere and explore the whole electromagnetic spectrum. And gamma-ray astronomy, when I started, was really in its infancy. We were flying physics experiments on high-altitude balloons looking at individual objects. And it's been my greatest pleasure to work in this field and help move it forward to now we have satellites that observe thousands of sources and contribute to the whole understanding by, adding in that gamma ray part of the spectrum. And the SWIFT satellite is looking at the gamma ray band specifically for flashes of gamma rays. They occur every few days, and they're due to tremendous explosions in the universe where stars are exploding and other types of gamma ray bursts come from stars that collide with each other. And whenever this happens, the SWIFT that's still flying now will send us messages, and we get paged on our cell phones, and we go running to our computers, which happily hasn't happened in the last hour. And it's really an adventure. It's an adventure science. So I'm so grateful to the start I got in my career from being here at Caltech. Thank you.